here goes our first attempt at flipping the classroom. This is Mr. Meyer at the Plush Way Happy Studios here in Livermore. And we are going to start section 4.7. And we are going to talk about inverse functions. So let's talk about inversing sine, cosine, and tangent and see what happens. So as you know, when you inverse a function, you switch x and y, solve for y, or you reflect it over the y equals x line, whichever one you like to do. And one quick check to do is that you could do a horizontal line test on a function to see if its inverse is a function. So really quickly, let me show you sine, and let's throw a horizontal line in. And if I slide that horizontal line around, notice it's hitting more than once, so sine's inverse is not a function. Same thing happens to our good friend cosine, obviously. And bad news, same thing happens to tangent. They are not functions. But then some clever folks figured out that if we restrict the domain, like looking at this tangent graph, if we only look from negative pi over 2 to pi over 2, we will have a function. It just repeats anyway, so let's just talk about that little range. Same thing with sine. If we only look at sine from negative pi over 2 to pi over 2, it will be a function, the inverse. And cosine's got a little trickier. We're going to have to go from 0 to pi over 2, and 0 to pi, and we will also have an inverse that is a function if we restrict those domains. So the good news, that's what we do. We restrict the domains. So as the domains are restricted for us, that means that we will be able to talk about the inverses and figure out what people are talking about when they give us, who has a sine of root 2 over 2? Who has a sine of, root 3? And you will have to figure out which angles these are. Now the good news is you have to keep yourself focused on the fact that arc sine, what I just erased here, arc sine is stuck in quadrants 1 and 4. So is arc tangent for that matter. And arc cosine lives in quadrants 1 and 2. Because we had to restrict their domains of the original ones of cosine. We had to restrict its domain so that the inverse could actually be a function. Now with that being the case, we should be happy enough to know that we can solve many inversing problems. So there are the graphs, and now we will look at how we solve these inversing problems. So the first thing you might run across is the notation. I can either use cosine to the negative 1 to denote inverses, or I could use the word arc. So as you see in example 1a, I'm using to the negative 1, while over in 1d, I'm using the word arc. Both mean the same thing. Tell me, whichever trig it is, tell me what angle has that answer for that trig function. So using 1a as our first example, I'm asking you, who has a cosine of 0? So hopefully your trick would be that you would look at your hand and you would say, well, cosine of 0 is the top fingers. So cosine of 0 means there'd be no fingers on the top, and that means I would have to fold down my thumb. And if I fold down my thumb, that means we're talking about a 90-degree angle, or pi over 2 in radians. So who has that cosine? That would be our good friend pi over 2. Now remember, we have to restrict ourselves for cosine in the quadrants 1 and 2, and that does fit in there, so we are good. All right, let's talk about arc sine. Arc sine is your bottom fingers. Who has a sine of 0? So again, I look at my fingers. The bottom fingers need to be 0, so that means we're going to fold over our pinky. There's nothing below our pinky. That means that we have a sine of 0. And we found our answer, that 0 degrees, or 0 radians, will be our answer to who has a sine of 0. Again, remembering that arc sine and arc tangent have to live in quadrants 1 and 4. So there's the other notation. In C, I notice that I might be in a little bit of trouble because on my hand, we always do it over 2 fingers, or over 2. We don't do it over root 2. So let's clean that up a little bit. Multiply top and bottom by root 2. That will give us root 2 over 2. And now I'm ready to figure out whose angle has 2 fingers on the top when I'm looking at sine. I'm sorry, 2 fingers on the bottom. So when I'm looking at sine, if I fold down my middle finger, I will have 2 fingers, which would represent root 2 over 2 like we want. So therefore, we must be talking about a 45-degree angle, or pi over 4. And we continue this pattern of just trying to figure out what angle is given to us. Let's do D, arctangent. Arctangent means a tangent of 1. So a tangent of 1 means that the bottom fingers over the top fingers would be 1. Well, there's only one way for that to happen. If I fold down 30 degrees, it's going to be 1 over root 3. Not going to work. If I fold down 60 degrees, not going to work. The only one that will work is that middle finger that will put root 2 over root 2, or also known as 1. We're talking about 45 degrees again. Sweet. So now I just go back and say, hey, you must be talking about pi over 4. Now notice, if that would have been a negative 1, we would have had to move that to quadrant 4 and said it was negative pi over 4. And hopefully that's coming up. Oh, yes, it is in F, G, and H. All right, let's talk about E. E says, who has a cosine of 1/2? Good that the denominator's 2. Means I can use my hand perfectly. Cosine is quadrants 1 and 2. Don't forget, go back to your hand. Cosine is the upper fingers. We only want to see one finger, so therefore we should fold this guy down. And if I do, that means we're talking about pi over 3 or 60 degrees. And now I know that that answer is pi over 3. So far hasn't been too tricky. Now let's see about this tangent. We have an arctangent of negative root 3. So tangent being bottom fingers over top fingers. That means there should be root 3, but be careful, it's negative. Well, to have bottom fingers be 3, you must be folding down your pi over 3 finger again. However, or 60 degrees. However, it's negative this time, meaning that that is the reference angle of whatever quadrant we are living in. So we know the angle is pi over 3. However, now I got to go to tangent, who lives in quadrants 1 and 4. And I can tell you that that reference angle then should be negative pi over 3 because we want to be in quadrant 4. Now arcsine, also quadrants 1 and 4. Who has an arcsine of negative root 3 over 2? Means that I should be looking at sine having root 3 fingers, or 3 fingers on the bottom. So sine is your bottom fingers. To leave 3 fingers, you'd have to fold down this guy. Hey, you're also talking about pi over 3. But remember, that is our reference angle since it was negative. So negative pi over 3 would also have an arcsine of negative root 3 over 2. And last but not least, arccosine. Arccosine of root 3 over 2, wow, it's negative. That means it's in quadrant 2, not quadrant 1, because everybody's positive in quadrant 1. In quadrant 2, we have negative root 3 over 2. If I go to my hand, cosine is the top fingers. I want to see 3 fingers on the top. Means fold down this guy, your old 30 degrees, or pi over 6. Now, pi over 6 is going to give us an angle in quadrant 2. Because here's where pi over 6 would be, and that's where cosine would be negative. So I just need to figure out what this angle measure is, and that angle measure, well, if this is pi, or 6/6, we'll subtract 1 off. This is 5 pi over 6. And there you have it. Using your hand and figuring out arccosines, arcsines, and arctangents, you can figure out whatever angle we are. Remember to restrict the domain. Remember that sine and tangent are only in quadrants 1 and 4, and cosine is in quadrant 1 and 2. Stay happy. All right, great job. And now let's move on to example 2. We're going to talk about compositions with inverse functions. So my big hints here, work from the inside out. And remember, if you're doing any arc, anything, to keep in mind the restrictions. Again, cosine and is in quadrants 1 and 2, and tangent and sine are in quadrant 1 and 4. So keep those in mind, because they're going to rear their ugly heads probably in this example somewhere. All right, so let's start at 2a. If I'm looking at 2a, I see the arc tangent of negative root 3. Arc meaning whose angle has a tangent of negative root 3. Obviously, we're talking quadrant 4 because this is a tangent who's negative. So if I want to see who has a tangent of negative root 3, I'm just going to talk about a quadrant 4 angle who has a tangent of root 3. So again, I'm going to go to my hand. Tangent is, sine over cosine or bottom over top. So I need root 3, meaning I need 3 fingers showing on the bottom. And there's my good friend pi over 3, who seems to be almost every answer in this example. But we will move on. It is pi over 3. So we are talking about a 60-degree angle, but in quadrant 4. So we are talking negative pi over 3. Now we at least know what angle they want to discuss. So I can tell you now that we want to know what is the sine of negative pi over 3. Or in other words, down in quadrant 4, the reference angle is pi over 3. Could you tell me the sine? And so yes, back to my hand, pi over 3. I'm going to fold you down, and your sine is root 3 over 2. And there's your answer. Whoa, wait a minute. All students take calculus. That we said was in quadrant 4, where sine should be negative. So the actual answer is negative root 3 over 2. So I can go back here and tell you the final answer to the sine is negative root 3 over 2. Remember to work inside out, starting first here, and then finally answering the question. And the question was sine, meaning give me the opposite over the hypotenuse. And there we go. All right, look at B. A lot of people think, hey, look, cosine and arc cosine, they cancel each other out. And for sometimes that is true, but you got to be very careful that when you're doing an arc cosine, you're only talking about quadrants 1 and 2. Look at that angle, 5 pi over 3. I don't think that's in quadrant 2. In fact, I know it's not. It's got to be in quadrant 4, because it's almost 2 pi. 6 pi over 3 would be 2 pi. That's just a pi over 3 short. So, in essence, pay attention, stay on your toes. So cosine of 5 pi over 3, well, cosine, that's just saying, hey, figure it out and you should be able to tell me the angle. Cosine, not arc cosine, because I'm working on the inside of the parentheses, working here. They're saying, hey, go to 5 pi over 3 and tell me the cosine. So again, I got to think of reference angle. Reference angle is definitely pi over 3, but be careful, it's in quadrant 4. So now when I go down here, reference angle is pi over 3. We're going to fold that down. And his cosine is going to be root 1 over 2, or 1 over 2, a half. So now that I know it's a half, I can go back and figure out the rest of the problem. I know that this is really asking me who has an arc cosine of 1/2. Now notice that in quadrant 4, we had to remember, all students take calculus, that cosine was positive. So that's why I didn't put negative 1/2 as the ratio. Now the next part of the question, who has a cosine of 1/2? So that's what arc cosine is saying. It's saying go back and tell me what angle has a cosine of 1/2. Now you would think it was just 5 pi over 3, but because this is arc cosine, we're restricted to quadrants 1 and 2. So who the heck in quadrants 1 and 2 would have a cosine of 1/2? It's obviously not 2 because it's not negative. So therefore, I'm only looking in quadrant 1. Who has a cosine of 1/2? Back to my hand, cosine of the top fingers. I'm going to fold this one down. There's my 1/2. And I know that the answer is pi over 3. That is the finger I pulled down. So finally I got pi over 3. So again, be super careful where you are and make sure you're paying attention to if it's an arc cosine or a regular cosine and what they're actually asking. When I ask you for cosine, I'm asking you to give me a relationship of adjacent over hypotenuse. But when I'm asking you for arc cosine, I'm asking you what angle has that relationship, and you're supposed to tell me an angle. All right, see you in a few. Excellent work. Keep it up. Now let's move on to example 3. Here's the tricky one. Let's get a little abstract on you. I'm going to take away the numbers. Just put in a variable x. And ask you, what is the sine of an angle who has the arc cosine of x? That sounds pretty tricky at first, but let's break it down in its little parts. The first thing I notice is that you want me to find the arc cosine of x. Who has what angle has a cosine of x? Well, draw a picture. Here's my triangle. Here's my angle. Notice I'm just kind of arbitrarily drawing it because trig ratios are going to be the same no matter where you are. And your cosine means that your adjacent over your hypotenuse is x. So that I know is guaranteed. Now we do have one problem. When I took arc cosine, remember the trick is we're in either quadrants 1 or 2. So how do we know which one we're in? And you're right, that's a little stressful. However, if I look at the second part of the problem where we're going to be taking the sine, in quadrant 1, sine is positive. In quadrant 2, sine is positive. So we don't have to worry. We're just going to do it in quadrant 1 where everybody's positive. But that was only because we were taking the sine and we were able to rule out any negative numbers. All right. Now, a little Pythagorean theorem tells me that a squared plus b squared equals c squared. So, looks like 1 squared minus x squared square rooted. That's got to be our missing side. Ugh. But we're done, right? If the cosine of some angle is x, then I can tell you the sine of that exact same angle has to be opposite over hypotenuse, which means 1 minus x squared over 1, or what most people would just call the square root of 1 minus x squared. Done. By the way, don't reduce that radical. It's tempting. You know the square root of 1, you know the square root of x squared, but that negative is holding them together. You know, if you want to check, factor it, you know it's a difference of squares. 1 minus x, 1 plus x. Those aren't the same, so it's not squared, so I can't cancel it. So can't do anything, and we're good. And there is the sine of the arc cosine of x. All right, let's try another one, just to make sure. Let's try the cotangent of the arc sine of 2x. Throw a 2 in there, maybe I'll scare you a little bit or something. I doubt it now. First thing I'm going to look at is who has an arc sine of 2x. Notice that we have to worry about being in quadrants 1 and 4. Good thing they're asking cotangent. They are also in quadrants 1 and 4. So life's feeling pretty good right now. I will draw a triangle that has a sine of 2x. So if you have a sine of 2x, that means your opposite is 2x, your hypotenuse is 1. Must be talking about that angle. Again, good friend Pythagorean theorem says that 1 squared minus 2x squared square rooted will get us the other side. So I think most of us would like to call that 1 minus 4x squared. And there's our triangle. Notice the x will be getting squared, so life is good. So now I can finally answer what the heck is cotangent. Tangent is opposite over adjacent, so cotangent would have to be adjacent 1 minus 4x squared over the opposite, 2x. Again, don't try to reduce because that square root, it's a difference of squares, 1 plus 2x and 1 minus 2x. Not going to help me in any way, so I am finished. Give one a try, and we'll see you later. Stay happy.